This is Group 10. Our project focused on using transformer method to generate standardized English test question and answer. Standardized English tests like TOEFL are important for non-native speakers. However, the practice results are very limited. This inspired us to develop a model that can generate similar question and reference answer. The specific test that we're dealing with is QA and QG test in NLP. Before, people used traditional rule-based and statistical method until neural net starts to take over. The state of art in this domain include transformer-based model like BERT, T5, GPT, and Albert. Such models are usually trained on larger corpus, such as with Wikipedia and Squad, where the contexts are short and the answer is contained directly in the context. In contrast, our model are tailored specifically for standardized English tests. We need to fine-tune T5 model, such as it can accept arbitrarily long English context and generate meaningful question. To this end, we built a context selector using an end-to-end memory network so that the model can focus only on relevant part in the passage. During inference, we also need an extra cause and effect extractor to extract sample question from the passage. Our task is difficult in that it requires a model to reason over the passage in order to generate meaningful question and answer, rather than simply copying words from the context. The dataset we are using are TOEFL listening and also RACE dataset, where RACE dataset is the English reading understanding test for Chinese high school students. And here are some example question and answer pairs.
So for question generation, we utilize T5-based model. We fine-tune the model on TOEFL QA as well as the RACE dataset. We also use the cause and effect model to extract causal relationship and include the information in context as a potential answer, so that our model may use this additional information for better generation. We also utilize the end-to-end memory model, which Jiayue will talk about in the next slide.
We implement the selection mechanism by adapting end-to-end memory networks. Given the reference question, it finds the most relevant sentences in the passage. The essence for this module is recurrent attention. The query network transforms the question to query embedding. The key and value network transforms sentences to key and value embeddings. We add residual connection from the initial query to output embedding and made it as the new query for next iteration. The weight matrices are shared across iterations like in RNN. The score vector of the final iteration is the output, and we try to select sentences based on this.
For question answering, we'll fine-tune the SOTA T5 on the TOEFL QA and RACE dataset. Since the input of the QA model are machine-generated questions, we don't have any ground truth labels, so we'll have to rely on human evaluation to assess the result of the QA model, and here's one of the examples. In this example, the passage is from a biology lecture in a TOEFL listening assignment. The machine-generated question we've got is, what does the professor imply about the translocation of animals? And the QA model responds with, the translocation of animals is the cause of many changes in animal life. You might argue that this is not a perfect answer because it doesn't provide the greatest amount of relevant information in a short sentence, but I will say from a standardized test perspective, it's a correct answer, so the output is still valid.
After question generation, we used the commonly used matrix to evaluate the generated question from our model. We chose to use BERT score, BLEU, ROGE, and Matiere. As shown in the table, the scores are overall improving with training, and the best model we achieved for TOEFL is the model with context, answer effect, and end-to-end memory network selector. We also noticed that there is a reduction in scores between 50th and 100th epoch for model fine-tuned on TOEFL with answers, and we suspect that it is due to a lack of data, which could lead to overfit. For RACE, with enough data, our model can achieve over 90% with matrix scores after merely 3 epochs, and the model with answers works substantially better than the model without. However, since question generation is not limited to ground truth, we have also evaluated the generated question manually and find that some questions with low matrix score are still answerable and grammatically correct.
To conclude this presentation, our main contribution is that our model is able to generate educational questions based on arbitrarily long articles. And as a result, it will enrich the learning resources for students at places where boot camps are not available, such as where people suffer from poverty. However, our model isn't perfect. There are 2 major limitations. First, for small data sets such as TOEFL, the model doesn't perform as well as larger data sets. The second point is that the model doesn't learn statistical distributions, and we can solve this by incorporating GANs or VAEs, but that's out of the scope for this paper. Thank you for watching.